and I hope everybody is fine. And today I'm going to talk about a very fascinating thing. I mean, everybody is aware about a very fundamental law of universe, what's called as Newton's universal law of gravitation, and where we can calculate the force between the two objects, knowing their masses and their inter separation. In resolving that equation, what we have the most fundamental reality of the universe. I may call this as the most dangerous number in the universe, and this number is none other than that of what we call as the gravitational constant. And all of us know that the value of this gravitational constant, capital G, is it's around about 6.6 times 10 to the power of minus 11 Newton meter square per kilogram square. Now, what if I told you that that the fate of the universe it depends, it depends on a number, and this number that I was talking about, that number with a decimal point involved in this number, and what we call as universal gravitational constant, and a number you can imagine so small that it looks harmless in equations, because it is 10 to the power of minus 11. And this is what we are going to talk about, a number so powerful that if it is changed by a few percent, then stars, planets, and believe me, life would disappear completely. And that number that I'm talking about, that number is called the gravitational constant. The gravitational constant that comes as resolving the natural relation between the force and masses and the separation between the masses. And its measured value is 6.674 times 10 to the power of minus 11 meter. Let me again remind you, 10 to the power of minus 11 Newton meter square per kilogram square. So this is the target that we want to talk about, that if there are slight variations in this number, and what we can expect from the existing universe. And today I want to show you how this tiny number quietly controls everything that exists in this universe. So to move on from here, the very first thing is that why this number matters. And to answer this question, gravity itself is simple. It's a simple mass. A mass attracts another mass. That's what gravity is. The attraction of one mass by another mass. But the key point here is the strength of that attraction is calculated, or this is given by this gravitational constant, G. This number, 6.617 to the power minus 11, this number decides it decides how fast objects fall onto the ground, and how tightly stars hold themselves together. It's decided by this gravitational constant. Now, the story does not go with star only. It extends to the galaxies, and this number decides the formation of galaxies, and whether the universe has time to grow complex, or it doesn't have any chance. Now let's imagine we turn cosmic this cosmic dial, and we turn it. We will not turn it dramatically, but we would like to turn it by a very, very simple number, just a little, and see what we can expect out of it. Now, say for example, if I say that G is stronger, and to give you the rough value, suppose the gravitational constant is twice than that of its present value. Now, what will be the twice of this gravitational constant? It will be nearly 1.3 times 10 to the power of minus 10 Newton meter square per kilogram square. And that looks very, very small if you compare it with the original gravitational constant that has been calculated. But inside a star, this change is enormous. This change is huge. This change is massive. The sun today has a core temperature roughly 15 million degrees Celsius, the core temperature of this sun. And what would we expect if we double if we double the gravitational constant? So by doubling the gravitational constant, what you are doing, you are doubling the gravitational force. So if you are doubling the gravitational force, the core of the star will compress. It will compress harder, and this compression will shoot. It will shoot the temperature. It will shoot the temperature nearly to 30 million degrees Celsius. In the number, it doesn't look so great. And what will happen to the nuclear reactions? The nuclear reactions would accelerate. They would accelerate violently. And what we are expecting, the sun will burn its hydrogen not in 10 billion years, as we can estimate from our current understanding of science, but perhaps if we calculate down, if we recalculate, it may perhaps take only few 100 million years to exhaust its core. And if we look around the life that we have, life needs billions of years to develop. It needs billions of years to transform into the complexity, into the complex form of organisms. So by merely doubling this G, stronger gravity removes that long span of time that has been used to create us. Now, if I take another example, if G were weaker, if this gravitational constant is weaker than that of the value that it has. Now imagine G were only half its value. So boil down this G to half its value, and what it will look like, 3.3 times 10 to the power of minus 11 Newton meter square per kilogram square. Now what will we expect? The gas clouds that normally collapse into a star they are about 100 trillion kilometers across. 100 trillion across kilometers bound by the gas and thus can form a star. At today's gravity, they slowly fall inwards, and then at some point there is ignition. That's what we call as the formation of the star. Now, what's going to happen with the weaker gravity? If the gravity is weak, these clouds that were spread up to 100 trillion kilometers, they will never reach even 10 million degrees Celsius, because 10 million degrees Celsius is needed for the nuclear ignition. With this weak magnetic field, so stars will fail to turn on. A star will not be formed. A universe with G nearly equal to 3.3 times 10 to the power of minus 11 kilogram Newton meter square per kilogram square would contain matter. There will be matter surrounding the clouds, but no stars, no light, and there will be no chemical reaction. There will be no chemistry beyond the formation of hydrogen and helium. So what do we expect with this? It would be a cold, unfinished universe. A universe cannot be built with this weaker part of gravitational constant that we are talking about. Now take an example of the galaxies. We have billions of galaxies, and these galaxies, they'll disappear. Galaxy like the one in which we are living, the one we call Milky Way, this galaxy contains nearly 100 to 400 billion stars. And these stars are held together by the gravity. There is a gravitational force between these stars over very, very large distances within the galaxy. And its diameter is 100,000 light years. This is the picture of our galaxy. Now, if gravitational constant is weaker, not even by half, if it is weaker by just 20%, the stars will fly off. They would drift away. And spiral arms that these galaxies have, these spiral arms will dissolve. They will dissolve into the lower atoms. Galaxies would not remain bound. So if G were stronger by 20%, what are we going to expect? The galaxies would collapse. They will collapse inwards in the framework of this constant, gravitational constant. And what would we expect about the black holes? The black holes will dominate the universe. They would dominate. And our galaxy exists on making those calculations. Our galaxy exists only because the gravitational constant, it sits in a narrow band. It sits in a band of 6.674 times 10 to the power of minus 11. To get more insight in this concept, talking about Earth, and what would we expect about the Earth, which is roaming around the sun, our the planet that we live on is roaming around the sun, and it is roaming at a speed of nearly 30 kilometers to 90 kilometers per second. Maybe I'm not correct about the value here. It's nearly 30 to 90 kilometers. And so there is a motion. So what we have is the motion of the planet Earth. This motion is balanced exactly by the gravity. Now, if the gravitational constant, if we only imagine that this gravitational constant is increased by just 5%, not more than 5%, Earth will spiral inwards. It will go on spiraling inwards. And what will happen to its temperature? The temperature will increase. It will go on increasing. And what would we expect about the oceans? The oceans would evaporate because the temperature of the planet is increasing as it's spiraling inwards. And if this G is decreased by 5%, what would happen? Earth would drift outwards. It would keep on drifting outwards, and the average temperature of this planet would fall because it's drifting outwards, outside of its defined orbit, and the temperature may go down up to minus 50 degrees Celsius. In that case, the oceans are gonna freeze. The oceans that are mounted on this planet are going to freeze. A 5% change in a decimal point number that I'm talking about would change the course, would change the framework, would change the beauty, would change the balance of this planet, and it destroys a living planet if you make this small change in the G. Now, if I take another example, when bodies must change on gravity, what would gravitational acceleration that we have here is 9.8 meter per second square on the surface of the Earth. Now, because the gravitational constant, capital G, that we have has its percent value. Now, if G were doubled, the universal gravitational constant, if we double the value of this gravitational constant, now gravity becomes automatically 19.6 meter per second square. So what's going to happen to your weight? Your weight over weight is going to double. And what about the bones? The bones must be twice as strong as they are right now. And what about the pumping heart? The heart must pump twice as hard as it is pumping right now. The tall trees that we have on the surface of this planet, the animals and the human bodies, they will all have to be different, and it would not be physically possible for any of them to exist if the value of G is doubled. Now, if at the same point of time, if the value of G is halved in this framework, the gravity becomes only 4.9 meter per second square, because the acceleration due to gravity is automatically going to halve. So what's going to happen? the muscles will have, we need weakened muscles. I mean, the movements will change, the dynamics will change, and the bodies, they will grow taller and maybe more fragile because of the weak gravitational force. So even biology is turned, even the biological life is turned, and it seems to be tuned to this number, the dangerous number 6.674 times 10 to the power of minus 11. And what about the fate of the universe? If we try to understand the fate of the universe in the framework of this universal gravitational constant, as we understand till now, the universe is expanding, and then this universe is expanding at a very, very alarming rate. It's nearly 70 kilometers per second per megaparsec. So these are the units, these are the astronomical units. That at this rate, the universe is expanding. And what's the job of the gravity? The gravity is pulling. It's pulling back. So gravity is an attraction. It's pulling these objects. Now, if G is large, this expansion would stop. It would stop as fast as possible. The universe would collapse in a big crunch. It will fall in a big crunch because the doubling G will bring its compression as early as possible. And if in the same expanding universe G is smaller, if it is small, matter would never be in a position to clump, and the clumping would not be possible. If there is no clumping, there are no stars, there are no galaxies, and there is no observable matter-oriented universe around us. So our universe survives because gravity and the expansion, they are balanced. There is a balance between the gravity and the expansion. Now, the very deep truth, the deep reality about this number is that this number is not powerful because it's not powerful because it's large. It is powerful. Maybe it's powerful because it's precise. It's more precise. And if it is too high, its too high value will lead to the collapse of the universe. And if it's too small, that will make a universe which is completely empty in terms of the visible universe. So only around 6.674 times 10 to the power of minus 11 Newton meter square per kilogram square does a universe with stars, planets, and thinking, thoughts. All of these things exist because of this precise value of gravitational constant. So the final argument is like, I would like to tell you that you should remember. You should remember this, that every galaxy that we have, every ocean that we have on the planet Earth, or every living mind or living creature that we have on this planet rests on a very cute decimal point. it rests on this very number, 6.674 10 to the power of minus 11 Newton meter per second square. And this is perhaps the silent miracle of the gravity. It is a universe that is held together by this mystical number. And we can realize that this number has a real fundamental reality that's governing this number. It's not the force between these galaxies that matters. It's not the force between the stars. It is just this number is right. That's why we have all of these things within us and surrounding us at the same point of time. So certainly there is a synchronization. There is an action going on. There's an action that's being predominantly acting on everything that's surrounding us, that's within us, and maybe we have no answer to explain that fundamental reality. But this is really a miracle that this number matters for the universe